Let's discuss primary fuses in power distribution, specifically concerning their rating and purpose on a residential transformer. The scenario you presented involves a 25 kV ampere transformer supplying a 240 volts or 120 volts 3-wire service with an impedance of 1.58%. You estimated a primary voltage of 4,800 volts, which is a reasonable assumption for many distribution systems. Given the transformer's secondary full load amperage of 104.17 amps, and estimating the primary current to be 5.21 amps, your calculations provide a foundation for understanding fuse selection. You correctly calculated the secondary short circuit amperage for a bolted line-to-line fault at 6,592.83 amps, and the corresponding primary amperage at 329.64 amps. The primary fuses are primarily for protecting the transformer. Transformers can be damaged by prolonged periods of overcurrent. The fuse rating is typically chosen to be slightly higher than the transformer's maximum load current. However, it's not so high that it will prevent the primary fuse from operating during a bolted line-to-line fault on the secondary side. In your example, a 10 amp fuse on the primary would be a plausible value. Some utilities might opt for circuit breakers instead of fuses on the primary side of the distribution transformer. Another significant concern associated with a secondary side bolted line-to-line fault is the potential for a pole fire. The intense current flow can vaporize the metal in the conductors, depositing it onto the pole as small beads. If the pole is sufficiently dry, these beads can ignite it.